Alrighty, this video is 12-4 angle measures and segment lengths. There's 3 theorems that you need to know. The first theorem, 12-13, says that the measure of an angle formed by 2 lines that intersect inside of a circle is half the sum of the measures of the intersected arcs. So basically, if you want to know the measure of angle 1, and choose a different color, angle 1, then you're going to add angle x to angle y and then divide it by 2. Okay, so basically 2 lines that intersect inside of a circle, remember that these angles are congruent because they're vertical angles, the 2 red ones. So if you want to know what one of those angles are, you just add the 2 arcs and divide them by 2. The second theorem that you need to know is theorem 12-14. The measure of an angle formed by 2 lines that intersect outside, so this is different, outside a circle is half the difference, and then there's difference when this one was sum of the measures of the intercepted arcs. So if we want to know what this angle is, then we would take the 2 angles that are inside. Notice here that we're looking at this angle and this angle. On this one, we're looking at this angle and this angle. On this one, we're looking at this angle and this angle. It's the arcs that are inside the 2 intersecting lines, and we subtract them and divide them by 2. So you have 3 different types of angles that you'll see. The third theorem that you need to know is theorem 12-15. It says for a given point and circle, the product of the lengths of the segments from the point to the circle is constant along any line through the point and circle. So basically, the length A times the length B is equal to the length C times the length D. In the second one, you'll see that the intersection point is outside of the circle. Oops. So in this case, if it's outside, then you add these 2 together and then multiply it by W. And then you add these 2 together and multiply it by y. The last one is when you have just 1 line outside and then 2 that go in. You add the 2 that are separated, multiply it by the outside, just like we did on this one, but then it's going to be equal to this one squared. Okay, and this theorem 12-15 is a little bit confusing, so you'll see it being used, and hopefully it'll help understand a little bit better. Alright, so for example 1, remember that we need to use our theorems here. So for example 1, it says what is the value of x? And x is an angle that is created by 2 lines that intersect inside of the circle. So we learned that x was equal to 1/2 the sum of those 2 arcs. So we add them together and divide them by 2, and we get 68. Alright, next question, example 2. This one says to find the value of z. Z is an arc measure. If you look back at your theorems that we wrote down, theorem 12-14 is the one we'll want to use here. And that one says that the angle that is outside of the circle that's created by 2 lines, in this case, it is equal to half the difference of those 2 intercepted arcs. So basically this is our formula. Notice here that the variable we're looking for is inside the parentheses, so we're going to have to use a little bit of algebra to get rid of that. Your first bet is to get rid of that 1/2. So we're going to multiply both sides by 2. So 40 is equal to 95 minus z. Then we're going to subtract 95 from both sides, and that's going to give us negative 55. And then we'll divide both sides by -1, and we get that it's 55. And you can just check your answer by plugging 55 back into our original formula. 55, subtract that from 95, and then divide that by 2, and you should get 20. Okay, so for this problem, this is a word problem, and this one's going to require a little bit more thinking than the other questions. It says a satellite is in a geostationary orbit above Earth's equator has a viewing angle of Earth formed by the 2 tangents to the equator. The viewing angle is about 17.5 degrees. What is the measure of the arc of Earth that is viewed from the satellite? Well, we know that in order to figure out arc lengths, in this case, we would take the measure of arc AEB and subtract the measure of arc AB from it, and that would give us the angle, which was 17.5. But also remember that you are dividing it by 2 or multiplying it by 1/2. In this case, we don't know anything about either one of the arcs, so we can call this one x and this one 360 minus x, and that can only be done because the two lines are tangent to the circle. So basically, in this case, the measure of arc AEB is 360 minus x, and then we're subtracting x again, so this becomes 360 minus 2x. And that's equal to 7.5. Goodness. So we're going to do the same thing we did before. Multiply both sides by 2, and then we can do our algebra. So I'm going to go ahead and do that, and then I will show you my results. Okay, so hopefully you tried it yourself, but if not, that's okay. I completed the problem, and I ended up getting 162.5 for x. So the measure of the arc of Earth that is viewed from the satellite is actually 162.5. That's the smaller one. If we wanted to find the other one, we would just subtract that from 360. So this is the last theorem that we went over. Basically, what we're going to have here is this outer portion, the inner portion, another outer portion, and an inner portion. And the theorem that we learned says that if you add 6 plus 8 and multiply that by 6, it is equal to 7 plus y times 7. And then we simplify this. So we distribute here and here. Actually, and it would be easier on this side if we added 8 plus 16, or 8 plus 6 first, and then multiplied that by 6. So 8 plus 6 is 14 times 6. That gives us 84. And on the left side, we get 49 plus 7y. Subtract 49 from both sides, and you get 35. Divide by 7, and you get 5. So hopefully that helps your understanding a little bit more. If you have any questions, come see me, and we'll see you guys soon.